Here's a page of text. No headings, no section breaks, no bold titles, just 12 paragraphs. And somewhere between paragraph 4 and paragraph 5, the author quietly stopped writing about the merger and started writing about the earnings forecast. No announcement, no meanwhile, or in other news. Just a pivot. Your eyes catch that. A machine does not. Unless we teach it to. This is text segmentation. Given a long document with no signposts, find the topic boundaries. A whole family of algorithms exists for this, and every retrieval system, meeting note summarizer, and long document LLM pipeline in production today depends on it. Last video opened Lecture 8 with the sentence to document jump. We named 4 new layers of structure: cohesion, coreference, topic segments, discourse relations. Today we zoom in on one of them, topic segments, where the document quietly changes subject. And the reason this is a task with its own name, a lot of the time, the segmentation is what a downstream system actually needs. Today's puzzle. If the author didn't mark the boundary, what signal is left on the page for a machine to pick up on? And the beautiful answer from Marti Hearst in 1997 is the vocabulary. When the topic shifts, the words shift. Track the vocabulary, find the dips, there are your boundaries. Today's 3 beats. First, TextTiling. Marti Hearst, 1997. The sliding window vocabulary similarity algorithm that is still the mental model everyone uses. Second, SN99 and the neural era. Divisive clustering, sentence embeddings, Wikipedia-trained boundary classifiers, Cohesion 2018. Third, why anyone still cares. Retrieval chunking, meeting notes, textbook indexing, summarization pipelines, the invisible workhorse. Beat 1. TextTiling. Marti Hearst, Berkeley, 1997. The problem statement: find topic boundaries in expository text with no headings. Her insight: a topic is characterized by its vocabulary. Adjacent chunks of text that talk about the same topic share a lot of words. Adjacent chunks that talk about different topics don't. So all you have to do is measure how much vocabulary 2 neighboring windows share and look for the low points. The math is almost embarrassingly simple. Turn each window into a bag of words. Compute the cosine similarity. Slide the pair of windows 1 position over. Compute again, and again, and again. Now you have a similarity score at every position in the document. Plot it. You get a wavy curve, mostly flat, with dips wherever the topic shifted. Local minima, that is where you put the boundaries. TextTiling is 30 years old. It still runs on modern documents, it still gives you a reasonable segmentation, and it uses no training data, no labels, no neural network, just word counts and cosine. That is a lot of mileage from one geometric intuition. And the reason it works is called lexical cohesion. Halliday and Hasan's 5th cohesion type from last video. Topic words repeat within a topic and swap when the topic swaps. Beat 2. What came next? Freddy, Choi, 2000. Algorithm called SN99. Instead of a sliding pair of windows, compute the similarity between every pair of sentences in the document. That gives you a big square matrix. Bright squares mean these sentences agree. Dark squares mean these sentences disagree. Now use divisive clustering to carve the matrix into rectangular blocks. Each block is a topic segment. The 2010s brought the obvious upgrade. Stop using bag of words. Use sentence embeddings. The same idea. Similarity between adjacent chunks, now measured in embedding space instead of counting overlapping tokens. Suddenly, a topic shift from merger to acquisition still looks like the same topic, because those 2 phrases embed to nearly the same vector. Bag of words could not see that. Embeddings can. Then Koshorek and colleagues 2018 supplied the missing ingredient, labeled data. They noticed that Wikipedia is already segmented. Every section header is a human-labeled topic boundary, millions of them, free. So they framed segmentation as a supervised sentence-level classification. Is this sentence the end of a section? Yes or no? Trained a bidirectional LSTM. Later, transformer versions, state-of-the-art overnight. Beat 3. Why anyone in 2026 still cares. Reason 1. Retrieval chunking. Every RAG pipeline in production has to slice long documents into chunks before it embeds them. Slice on arbitrary character counts and you cut mid-topic. Slice on real topic boundaries and each chunk is coherent. Better retrieval. Better answers. Segmentation is the unsexy plumbing that makes RAG actually work. Reason 2. Meeting transcripts. Long. Unstructured. Nobody types section headers into a Zoom call. A summarizer that runs on the whole transcript at once produces mush. Segment it first into topical stretches, roadmap discussion, hiring update, Q4 numbers. Now the summarizer has coherent inputs. Better summaries. Reason 3. Textbook indexing. Long-form docs like textbooks are almost pre-segmented by chapters, but subsections and sub-subsections need machine-detected boundaries for search and cross-reference. The through line. Segmentation looks trivial when a human does it. It is hard for a machine because the signal is diffuse, spread across dozens of sentences, tangled up with pronouns and connectors. But the story from 1997 to today is one of the cleanest arcs in NLP vocabulary. Cosine gave you the shape. Embeddings sharpened the metric. Wikipedia gave you free labels. And now segmentation is a solved-ish problem that nobody names in press releases and everybody uses in production. 3 takeaways before the quiz. 1. TextTiling from Hearst 1997 is the mental model. Slide 2 windows across the document. Measure vocabulary similarity. Put boundaries at the local minima. No training, no labels. Still works. 2. The modern stack replaced bag of words with sentence embeddings and added Wikipedia section headers as free supervision. Cohesion 2018 was the flip point. Neural approaches now dominate benchmarks. 3. Nobody sells a segmentation product. Everybody ships one inside RAG pipelines, meeting summarizers and long doc LLM systems. Segmentation is the silent workhorse. Quiz 1. What is the core signal TextTiling uses to detect topic boundaries? A punctuation frequency. More commas mean a boundary is near. B. Vocabulary similarity between adjacent windows, dips, and shared words mark topic boundaries. C. Sentence length. Longer sentences mean a new topic. Or D. The presence of the word however. B. Lexical cohesion in action. 2 neighboring windows that share a lot of words are almost certainly on the same topic. 2 neighboring windows with a big vocabulary swap are almost certainly straddling a boundary. Cosine similarity on bags of words. That is the whole method. Quiz 2. What did Koshorek et al. 2018 do differently that pushed neural segmentation forward? A. They invented a new nonlinearity that replaced ReLU. B. They noticed Wikipedia section headers are pre-labeled topic boundaries, giving millions of free training examples. C. They translated TextTiling into French. Or D. They removed the sliding window entirely. B. Wikipedia gave the community a huge, free, human-labeled segmentation corpus. Every "is this the last sentence of a section" becomes a supervised binary classification. Train a by LSTM, later a transformer, state-of-the-art overnight. Quiz 3. Why does text segmentation matter for retrieval augmented generation? A. It doesn't. RAG doesn't use segmentation. B. Chunking on real topic boundaries beats fixed-length chunks. Each chunk is coherent. Retrieval and answer quality improve. C. It compresses documents to save disk space. Or D. It replaces the vector database entirely. B. This is the practical reason segmentation is a working NLP task in 2026. Every serious RAG system does topic-aware chunking. Cut a paragraph mid-topic and you get a chunk that embeds to noise. Cut at real boundaries and each chunk holds one idea. Retrieval sharpens, answers sharpen. Back to the puzzle. When the author didn't announce the topic shift, what signal is left on the page? Answer: the vocabulary. Track it. Find the dips. That single geometric idea has powered text segmentation from 1997 to now, upgraded through embeddings and neural supervision. Next video, does sentence X imply sentence Y? Textual entailment. Next time, textual entailment. Given premise and hypothesis, does the first imply the second, contradict it, or neither? The SNLI dataset, the 3-way NLI setup. and how modern LLMs quietly ace the benchmark while still failing adversarial versions. Hit subscribe